Okay, so this is part 2 of the learning target number 1 notes. And these are 2 different scenarios that you haven't looked at yet. So we talked about the scenario on yesterday where we talked about systems of equations and what it was. This is going to be a different kind of system, but something else kind of happens, which is interesting. Okay? All right, so this scenario says Miss Summers and Miss Peterson are having a competition. Miss Peterson can create 10 math problems every 5 minutes, and Miss Summers can create 4 problems every 2 minutes. When will they make the same number of problems? So we're going to do a table per teacher. So we'll talk about Miss Peterson first. We'll do her here. Okay. And then we'll do Miss Summers over here. So, it says Miss Peterson can create 10 math problems every 5 minutes. All right, so at 0 minutes, how many math problems has she created? None. Okay. All right, so then every 5 minutes, I can create 10 problems. So, after 5 minutes have gone by, I've created 10 problems. After 10 minutes have gone by, I've created 20 problems. Then I can do 15, 20, 25, keep going, 30, 40, 50. Okay, there's 1. All right, now let's look at Miss Summers. Miss Summers can create 4 problems every 2 minutes. So at 0 minutes, she's created 0 problems. At 2 minutes, she created 4, and then she counts by 2 here. And then she goes 4, then I go 8, 12, 16, 20. Okay. So if you look, let's kind of predict where they're going to be the same. So in this table, I see 2 places where they're the same. So they're the same here, they're the same here, but they're also the same with 10 and 20, which is weird because we kind of talked about how lines can either have 1 intersection, no intersection, or infinite intersections. So the fact that they have 2 is just a little weird to me. So let's see what happens. This is why we graph things. Let's create some couple equations to model it, all right? So I noticed that they have 2 intersection points. All right. So in order to create equations, remember, and this is a linear equation because it's giving me a rate. Every 5 minutes something happens, or every 2 minutes something happens. So Miss Peterson can create 10 problems every 2 minutes. So that means every minute she creates 2 problems. So I could say y equals 2x for her. And Miss Summers can create 4 problems every 2 minutes, which is actually, again, just 2 problems per minute. So these situations or scenarios are actually the same. So they actually create the same amount of problems all the time because they have the same slope or the same rate at every minute. So let's just confer this. So it looks, I think on yours you might have a scale of 2. I want you to change it to the scale of 1. So you can just kind of write over your numbers and just put a scale of 1 here. And the reason I'm going to have you do this is just so you can see it a little better what's happening in the tables. So math problems are going to be here, number of math problems. And minutes are going to be down here. All right, so Miss Peterson has 0, 0, and then I can plot the point 10. Oh, I can't even plot the point 10, 20, so that's going to be kind of hard. I can plot the point 5, 10, though, which is going to be here. So it looks like I can do this. I'm going to do this. So this is Miss Peterson's. I'm going to do that in blue. I'll put a P next to it. And then I'm going to do Miss Summers. 0, 0 is also her point, and then I'm also going to do 4, 8. Oh, look, that's already on my line. These are all actually already on my line. So these lines are actually going to be the same. I'll put an S there. So what do you notice? How many solutions are there? Well, they cross infinite times. They're the same all the time, so they're infinite solutions, which means they're always the same. So here's a scenario where we have two equations, but they're actually the same. Two situations, they're just kind of presented to us in different ways. So you could see this too, depending on what problem you have, but this is an example or an infinite solution problem with a system of equations. Okay. All right, let's look at that second scenario here on the next page, page 8. It talks about Mr. Reininger and Mr. Yu, who are also involved in this competition. Mr. already has 4 problems created and makes 1 problem per minute. Mr. Yu has 2 problems done and also makes 1 problem per minute. So it's asked when will they make the same amount of problems. So let's talk about Mr. R first. So he already has 4 math problems done. That means at 0 minutes, he's already have 4 problems done. And then he creates 1 problem per minute. So at 1 minute, he creates 5, 2. So I'm going to just create this table here. All right, so there's Mr. R. Pretty straightforward. Mr. U already has 2 math problems done, and then he does 1 problem every minute as well. So 3, 4, 5, 6, 7. Okay, so there I have tables to model, and if I look at the tables, I don't see any places where they're the same. So maybe I have to graph them, and then I can hopefully be able. But we can say here there's not a common point. So let's look at these equations. Okay, so Mr. R starts with 4, that's my y-intercept, and then he creates 1 per minute. So 1x plus 4 would be our equation there. And then y equals 2 plus 1x. What do you notice about those equations? You should say, hey, they both have a 1x, which means their slope is both 1, which is kind of crazy. So let's see what happens when we graph it. We're going to do, if you already have a scale by 2, just change it to 1. So 1, 2, 3. And again, our x's are going to be minutes. It's always important to label. And then on this axis, we're going to go up by 1s as well. So 1, 2, 3, 4. All right, so I'm going to put Mr. R in blue. So he starts at 0, 4, which is here. And then he's going to go 1 problem every minute. So then he goes 5. Okay. So I can see the pattern that's going here. And I can just connect the dots. Okay. And then I'm going to do the same. So this is Mr. R, I'll label R. And then I'm going to do Mr. U in purple. So he starts off at 2 problems and he goes 1. Okay, so it's going to go like this. This is great. So here we go. Oh, I see what's happening here. Mr. U. So if you look, what's happening to my lines? Will they ever intersect? Doesn't look like it, which means these lines are parallel and they'll never intersect, and therefore they'll never be the same. So this is an example of a system with no solutions. There will never be a time where they will make the same amount of problems. Okay, so that is an example of no solutions. We looked at infinite solutions, and we looked at 1 solution in the last video. So these are the 3 kind of scenarios that you'll see throughout this whole unit that you want to be mindful of.